In this problem, we're going to be working with addition reactions to alkenes. In particularly, we're going to be doing hydrohalogenation and then elimination reaction. We're being asked to predict products of these three sequences, the three different reactions. So let's do that. First step here, we see the first reaction is a hydrohalogenation, and then follow in another step by treatment with potassium terbutoxide. So let's look at the first reaction. For the first reaction, the product will be hydrohalogenation, and this is Markovnikov. What that means is we're going to put the H here and the bromine here. So that's the first step that you will do. H here, bromine here, that's what you have. Then the second reaction says potassium terbutoxide. Okay, so now what we have here is a bulky base. We know that terbutoxide, let's see, we have that. Metal, 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 and that's an oxygen, and that's a counter ion, very big. So the mechanism here is E2, and if you need to review that, I have more videos on E2 mechanism with different bases. So back here, since it's a bulky base, this is going to favor the Hofmann product. So, which is a least substituted alkene. So if the Hofmann product is what is going to form, you're going to eliminate with one of the beta hydrogens at the metal group. So let's label, this is your alpha carbon. You will have beta hydrogens here, here, and here. But since you're using a bulky base, you're going to eliminate with the beta hydrogens, giving the least substituted alkene. So your final product is this. That is a first reaction on the top. Let's see what happens if we change, this time, the base. So we're going to be forming the same as the Markovnikov addition, but after we form that, let's say from that point, if we treat with sodium ethoxide, which is the second step that we have here, what you will form is then the side-step product. Remember that we labeled here, beta hydrogens are here, here, and here, but this time you're going to form the more substituted alkene, so your product is this alkene. So different products, we're just changing that base. That's the Hofmann product, this is the side-step. Okay, now what happens in the third reaction? No, well, let me just label that, that's Hofmann, and that is side-step alkene. And differences, the alkene here is tri-substituted, this is di-substituted. All right, so now for the reaction below, we have again hydrohalogenation, but this time we have peroxides. We need to remember that in the presence of peroxide, this happens anti-Markovnikov. So if this is so, and we're forming the anti-Markovnikov alkene, you will be adding then the H here and the bromine here. So let's do that. H at the more substituted, bromine at the least substituted. Now you have a different bromide, yes? And now it says that you're treating with potassium terbutoxide. So here, again, is a bulky base, and if this is your alpha carbon here, you will have beta hydrogen. Here you have 1, 2, 3, so 1 here, and you have 2 hydrogens here. So possible alkenes is doing the E2 elimination over here, but that will be the side-step product. This side has less steric hindrance, that's the least substituted alkene. So if you treat it with potassium terbutoxide, you're going to form the alkene that is less substituted. So let's draw it. Oh, I think I can draw that with this. You're still going to have the metal here, and you're going to form that alkene. Notice 3 different products. And yet, let's see what happens if we start from here. And this time, I'm going to use the first condition with peroxide, so I'm going to start from the same alkene, but now I'm changing the second step. I'm going to use sodium ethoxide. And again, that is a different thing. If we start using the hydrohalogenation with peroxide, and we start here in that product, and we treat it with sodium ethoxide, now this will form preferentially the decisive product, and that is another alkene. This one. So notice all the products that we have for now, this product is the same as that, but overall we have formed, using all of these conditions, we have used hydrohalogenation, both Markovnikov and anti-Markovnikov, and followed by an elimination. So we have to pay attention what is the condition. First, look at the reagent and determine what is the reaction that's going on. So first reagent was hydrohalogenation, so it would be Markovnikov addition, and you have that. Second, the other reagent was changing in this too. First product is that second reaction, the elimination. In the first case, you use a bulky base, and that will give you preferentially is the Hoffman product, the least substituted alkene. The second, you use sodium ethoxide, you get more decisive. In the other reaction, what we did is change it, and we use peroxide in the hydrohalogenation. That changed the orientation of the addition here. So we had the bromine at the least substituted. And from these halide, we'd use a couple bases in the first case. This is with potassium tributoxide. Okay. And in the second case, so here you will form the Hoffman, so here. And in the other case, you will do the alkene here, which is the decisive in that case. All right. We'll keep working with more reactions. So this is all about predicting products, and here we are combining addition to alkenes and then elimination reactions.